Hi everyone, this is a recorded video for the 17th of January 2018. I'm sure you all know that classes are canceled today because of inclement weather. We got those early morning texts and emails and calls from the university. So this video is provided so that we don't fall too far behind on schedule. The issue is we've got a lot of material to cover this semester, and that material doesn't go away just because the university canceled class. And so this is much better than us trying to cram a bunch of information into later lectures. It'll kind of help us stay on track, and so hopefully this is just a pretty straightforward way for you to receive the material today. Let's begin with a couple of announcements here. First of all, Homework 2 is still going to be due on Friday the 19th, and that's the original date that was identified on our course schedule. You know, the document, the table that I gave you on the first day of class that shows every topic for the semester and when each assignment is going to be due. So it's the same day, but I'm pushing back the submission deadline to 5 p.m. Ordinarily, you'd be required to upload the assignment before we have our class meeting, and so the normal deadline was going to be at noon on Friday. However, just to provide you a little bit of extra leeway there, I'm pushing it back to 5 p.m. in case there are any questions that you'd like to ask at the beginning of class when we meet on Friday. So I'm not going to introduce any additional hints. I'm not going to show you how to do any of that homework. It's just simply if you already attempted it and have some questions, and if there's anything that I can clear up. All right, so Friday at 5. Today we're going to be talking about some continuation of the ideas from the previous lecture, which had to do with cash flows. We'll look at a few more cash flow diagrams today in the course of our lecture, but the focus of the material is going to be on the idea of economic equivalence. And I'll encourage you to read up on this idea from the textbook. It's in section 7 of chapter 1. If you're not already, I strongly encourage you to take just a few moments each day to preview the material that we're going to have in class, and then a little bit more time after the lecture to review it in additional detail. Now there is an in-class exercise, I guess it's maybe an out-of-class exercise at this point, called Economic Equivalence. That's a PDF file that I emailed you along with the link to this video. If you couldn't find that, it's also the PDF, and the link to this video is posted on MU Online. So it's important that you have that printed out and in front of you, because during certain periods of today's lecture I'm going to pause the record. Well, I'm going to ask you to pause the recording and work through the in-class exercise just so you get some initial practice on these ideas. Remember, the idea is that if you start with the very simple material from the in-class exercise, then the homework is a little bit easier, and if you do the homework, then the quizzes are a little bit easier, and if you are well acquainted with the homework and exercises and quizzes and lecture material, then you'll do just fine on the exams. All right, with all that said, please send me an email if you have any questions, or if I can answer any concerns that you might have. Otherwise, hopefully, I'll see you in class on Friday. Now, the bulk of this lecture has been recorded in a previous semester, but I will break in with some additional, more recent information when it comes to the in-class exercises.
All right, so what I mean by economic equivalence is talking about how the effect of interest rate and time changes the value of money. And so we've, in the previous classes, calculated how much will be some future amount based on a known present value and an interest rate. What we mean by economically equivalent is that it doesn't matter if you have the money now or in the future, that if you do the conversion at the interest rate in question, that they have the same value. So let's talk about the different kinds of interest rates. For example, if we're talking about inflation, which is the interest rate that governs the change in prices, then we could look at how the price of a candy bar in the past compares to a price of a candy bar today. The equivalent price between the two, you'd use inflation as the interest rate. Or if we're talking about putting money into a savings account, then you wouldn't use the inflation rate, you'd use the rate that's being paid by the bank. But economic equivalence is just trying to solve the cash flow diagram type problems to find out how much money is equal, but just converting a present to a future, or a future to present, or sometimes we'll do these annual series as well. So you'll prepare a cash flow diagram similar to what you saw previously, where you have 1, 2, and so on, representing whatever the time periods are. And then you're doing the compounding or the discounting at I. And what I mean by compounding is anytime you move an amount from the present into the future, that's called compounding the amount, and it increases when you've got a positive interest rate. And discounting is when you're moving money from the future backwards, and it reduces the amount when you have a positive interest rate. So here's an illustration. Let's say that you make a deposit of $100 now into an account that earns a rate of return of 10% per year. That means at the end of the first year, at year 1, you can withdraw $110 from that account. Now by the way, this is a slide from the textbook author, and so one of the things that struck me about this is that we're talking about economic equivalence, and yet the signs are in the opposite direction. And so sometimes it's easy to get tripped up on the directionality of the signs, because we'd be thinking, well, economic equivalence should mean that if you have a deposit now, that's a line down, then shouldn't the line be also down in the future? And I can definitely understand that point of view. But this illustration is just saying if you're putting it into a bank account, and so an investment means that in the future you can do a withdrawal. So don't let the directionality of these arrows on this illustration distract from what we're really saying is that 110 in the future is economically equivalent to the 100 now. This is the simplest illustration. When we have some of the cash flow diagrams in the future, you're going to really wish that we had the simplicity of this illustration. So let's look at some of those. These cash flow diagrams can actually work as kind of a shorthand for the problem statement. You can look at a picture and not necessarily even have to have any accompanying text to do the calculations. So in this first one, what we have is a present amount of $11,000, and is that a deposit or a withdrawal in year 0? From your point of view, let's say that this is illustrating your point of view. In year 0, do you deposit $11,000 or do you receive $11,000? Deposit, right. So anytime the line is down, that's a cash outflow. So what this problem statement is saying is find the future amount given some known present value. So again, just let's use this notation through the semester that when you're trying to find an unknown, the line and the arrow will be dashed. That just kind of maybe suggests an unknown height of how much it's going to be. Of course, you know, these question marks make it pretty obvious that it's the future amount that you're trying to find. Now, we put it in this order, find F given P. You could have said it given P, find F. But actually, I'm going to phrase all of these short summaries in this way because the even shorter way to summarize this problem is F/P. And we're going to do a problem-solving method that uses pre-calculated ratios. What we'll look at in the back of your book, in fact, if you've already purchased the book, there's table after table of all of these factors based on different interest rates. And what you can do when you're utilizing those tables is you'll simply multiply that factor by this ratio. So if you know the given P, then you can multiply that amount of P by the ratio from the back of the book and find F. So we'll look at the formula methods and you'll know how to solve those formulas, but then even easier is to use the ratio of the future to the present and then multiply it by the factor that you can look up from a table. Okay, so here's another picture. It's a little bit different from the first one. How would you summarize what this problem is saying? In the same way that we said find F given P. So what is this one? Exactly. Find P given F. Or even more simply, P/F. So this one, we have some future amount that we know, and we want to find out how much would we have to deposit now to make this amount available in the future. All right. So we can do the same thing with annual series. Now just to refresh your memory, anytime the arrows appear to be about the same height and you've got the A above it, that means that they are going to be the same amounts every year. So what we're looking at here, this picture is telling the story of deposit $7,500 now, and what is the amount that you can withdraw for the next 3 years. And then not pictured is the fact that what you expect is there's going to be zero balance after those withdrawals. So, you know, it may be possible that you want to have a little bit left over in later years. If so, you need to include that in the diagram. Because what you should assume is that when you see this illustration, it's just that all of the money is taken out in the course of 3 equal withdrawals, 3 annual withdrawals. So this is find A given P. So A/P, meaning that you look up the factor in the back of the book. If you know the amount P, then you can just multiply that 7,500 by the factor, and that will tell you what the amount can be for you to withdraw. All right, last one. Find P given A. So I think over time you'll see enough of these cash flow diagrams that it'll become almost second nature, like the visual language of these economic equivalences will be very easy.
All right, so let's take a look at the in-class exercise for today, economic equivalence. In this first problem, we know a fixed amount that we want to receive next year. So we want to receive AED 95,000. By the way, that currency is dirhams. It's the currency of the United Arab Emirates. So we want to receive 95,000 of them next year from an account that's paying 9% annual interest. And so what you're going to be solving for in part A is how much do you want to deposit today if the final amount, meaning the interest and the principal together combined, is equal to 95,000. And then in part B, draw a cash flow diagram that illustrates this situation from your perspective. All right, so what I'd like you to do, hopefully you have that printout in front of you. Pause this recording right now for just a moment. Work through the in-class exercise, give it your best shot. Of course, if you get stuck, I'm going to show you the solution in just a minute. But actually, do take a moment and try and solve this so that you can learn from the experience of trying to break down this problem into the 2 parts. All right, so let's take a look at the solution for this first problem in the economic equivalence in-class exercise. So we know that if you want the finishing amount to be 95,000, that's going to require a deposit today. And this 1.09, what we're doing there, the 1 refers to the principal, the 0.09 is the interest, and so that means at the end of the year we're going to have 1.09 times the initial deposit. So you'll see that the initial deposit should be 87,155.96. And if you want to double check that, then of course all you have to do is multiply this value by 0.09, and that will give you the interest that would be earned during the 1 year, and then add the interest to the principal, which is this amount, and then hopefully what you'll find is that the finishing value is 95,000. All right, so for the cash flow diagram, take a look at this. We have our horizontal line, which refers to time. 0 is now, 1 is 1 year into the future. And so what we're going to do is we want to receive the money next year. So we're going to have money coming to us, which is an arrow up, in the amount of a future value, 95,000. And so that means that the present value, the amount that we have to deposit now, is 87,155.96. So the downward arrow means that we make a deposit today, and that enables us to make a withdrawal 1 year into the future. Okay, so now let's take a look at the second part of the in-class exercise. In this question, we have a situation where we're going to receive 4 equal annual payments of 12,500, and there's 5% annual interest. And so it's kind of like we're getting a loan in 1, 2, 3, 4 installments, and then what we have to do is we have to pay it back all in year 4. So Here's some hints here on how to solve the problem. First of all, we get a certain amount in year 0, 12,500. So how much is that worth by the time we get to year 1? In other words, we have to multiply 1.05 times this value, and then that's going to take it to year 1. And then we're going to combine that amount that was previously in year 0 with the amount that is already in year 1, so with the 12,500. And then those two figures, once they're added together, you're going to move that from year 1 to year 2 by multiplying by 1.05, and then combine it with the amount that's already in year 2, 12,500, and so on and so on. So there's a pattern there. And in the end, we're going to find out what's the value of those 4 payments if we move all of the amounts to year 4. So essentially what we're going to be doing here is manually finding the effect of compound interest, which we'll talk about in more detail later. But the first step that you need to find out is basically this 12,500 that's here in year 0 to begin with. If you move that to year 1, meaning if you're finding out what's the equivalent value in year 1 because of the interest that has to be paid, then combine it with the amount that's already in year 1. All right, so pause the recording, take a few moments, and try and solve this problem. Okay, so let's take a look at the solution for this one. As you can see, there's the 12,500 that's in year 0, and we want to move it from year 0 to year 1. So that's kind of what this notation is referring to. So the 12,500 in year 0 is accumulating some interest. And by the end of the first year, meaning at year 1, that 12,500, you now owe the bank 13,125. But then they give you another 12,500 right at that same moment. And so now you owe them even more. You owe them the 13,125, which was related to the amount you received in year 0. And now you also instantaneously owe them the amount that they just gave you. So they gave you 12,500, you owe them that. So this 25,625 represents, after they've given you the second installment of the loan, how much you owe them. Okay, so now we take that amount that is in year 1 and we're moving it to year 2. So we want to find out this balance when you have the interest accumulating during that 1-year period, how much is owed at the end of the second year. And it turns out that it's 26,906. So that's the value of all the 2 payments you've received so far. But then, of course, you receive this third payment of 12,500. So now we have to combine the third payment of 12,500 to the balance that's accumulated so far, and then the new amount that's owed is 39,406.25. Same pattern repeats itself. We have this balance, all of it now we're in year 2, and we're moving on to year 3. So we find out the balance and the effective interest, how much it accumulates to, the next installment of the funds that we receive from the bank, adding it all together, there's a new balance. It accumulates interest for one final year, and so the total amount that we owe at the end of the 4th year, and that's what we have to pay back, is $56,750.39. So that shows you kind of the effect of compounding interest over time. I hope that you detected the pattern there and could simulate the similar thing in the future. I think there's maybe a problem related to this in the homework, but if this just doesn't quite sink in, try it again a little bit later. Sometimes it takes some time to stew in the mind before it makes sense. And of course, you can always stop by during my office hours and we can go over it together. All right, so one more in-class exercise. Let's look at this one. We need aviation fuel. It is $2.20 per liter. And in 3 years, we expect the price to be $2.65. So I guess there's inflation happening in the fuel market, and we expect that it's going to be more expensive in the future. In 3 years, we know that we're going to have 100,000 liters of the fuel. So we're considering 2 ways of having that fuel available. You could either buy it now at the low price, but then you're going to have to store it during the 3 years. And it turns out that if we want to store that fuel for 3 years, it's going to cost us some money. It's going to cost $40,000 to hold the fuel for 3 years. So that's one option. So find out what's the total cost of that option. And once you do, take that same amount, which means the fuel cost and the storage fee, the same total amount from Part A, put it into a savings account, and then over the 3 years, let's say that that savings account returns 20%. And that's not 20% per year, that's 20% for the 3-year time period. So find out how much money you'd have in the account if you made that investment, purchase the fuel at the higher $2.65 per liter rate, and then find out if there's any money left over, or maybe you won't have enough money. And that's what tells you which option is better, is if you have money left over by doing option B, or if you don't have money left over, then that would mean option A is better. All right, so pause the recording, take a moment to work through those calculations, and then start the recording again when you're ready to see the solution. Okay, so here's the solution. By the way, I've changed the currencies a bit, but the calculations are the same. If you buy the fuel now, you're going to pay $220,000 for the fuel, and then there's also the storage fee. So the total cost combining the two, $260,000. So option B says, let's take that same amount, which we were going to spend anyway on the fuel, but rather than buying the fuel and storing it, why not just take the money and put it in the bank? So the 20% return, that's the interest you're going to earn on the savings, $52,000. So combine that $52,000 with how much you actually put into the bank, and the total available that you'll have at the end of the 3 years that you could withdraw and purchase the fuel, you'll have $312,000. So now you use that money and buy the fuel at the higher price, the $2.65 per liter. So that means you're going to spend $265,000 on the fuel, and since that's less than the total amount you have available, you have an excess. You've got some money left over. You've got $47,000 left over. So that tells you option B is better. It's better to invest the money, and then you'll have some additional cash that you can use for whatever you need. All right. So that is the end of the recorded lecture for today. Just please remember that for the homework assignment, it's still going to be due on Friday, but you'll have until 5 p.m. to upload that to MU Online. Please stop by my office or send me an email if you have any questions, and try to stay safe and keep warm. Bye-bye.